Hi, we are Team Harker Heights, and this is our midterm presentation. So this is our team. We have 3 urban planning managers and 2 comp managers.
Background of Harker Heights, it's located in Bexar County, half between Austin and Waco, part of Gillian, Temple, and Fort Worth. This is the 3rd largest city in the county. The population is 32,400 residents in 2019 U.S. Census, and median annual income is 72,600. The major community is veteran, and the race distribution is 64% white, 22% Hispanic, 20% Black, and 5% Asian. So we had the first meeting on February 11th with Senior Planner Courtney Paris, and we discussed about our proposed plan to enhance town's currently low walkability and connectedness via temporary painted sidewalk and visibility and community approval of the project, implementing a sidewalk and obtaining data from the city to help create machine learning and some of our challenges that streetscape and landmark, also 190 traffic funds and holistic mindset that projects are beneficial. And we had another meeting through the email on March 8th. We discussed the top 10 ranked location for sidewalk installation and city's concern around safety and ultimately liability should anyone be injured. And we ultimately need to get approval from the Public Works Department as well as police and fire department. Sorry.
So there are many challenges involved in pulling off this project. First off, several states are off limits due to being maintained essentially by state governments. We also have some struggles with getting a sufficient amount of data. We have only currently 58 data points of actual car crashes, and all of those are unfortunately fatal car crashes right now. There isn't data available for non-fatal car crashes, and only some of that data involves rescue. Additionally, some of the useful characteristics from this data cannot be quantified for trees without accidents, such as the number of pedestrians involved, fatalities, and the latitude plus longitude. Finally, our quantitative output data, essentially saying how safe the street is numerically, it doesn't exist, right? The machine learning model would come up with that. It can't take the data from somewhere else that already knows that, hey, street is 30 and safety out of 100 or something. So we don't have the data. The sidewalks are also missing and connected in the city itself. We have to convince many different people within the city to pull this project off and implement it properly. And we need to prioritize mobility followed by connectivity.
So getting into detail on the painted sidewalks, this is a form of taxable urbanism. It's also known as urbanism, pop urbanism, to repair. It's a low-cost temporary change to the already built environment, usually in cities, and it's intended to improve local neighborhoods. It's mainly used in areas where sidewalks are not present to create a connectivity, and it's also been used in a variety of larger cities. Some of the potential benefits of doing painted sidewalks is that they're quick, they add color to the city, they're very useful, much easier option, very cost efficient, and it gets the community involved.
So in terms of the data that we have for analyzing where we want to have the sidewalks, we found a data source online called citydata.com, and we were able to scrape this data and come up with a list of data points that are fairly useful for us. We're also able to augment some of the data from the ArcGIS data source and add it to this one. So we have speed limit and also the distance from bars. And this is more data from ArcGIS. We found that it might be useful to have the road name and the road type, as well as some of the data points have paved width. So these data points might be useful in determining whether or not where to put the sidewalks. And then finally, here's a chart that I made that details what percentage of, or a bar chart that expresses the fatal accidents with pedestrians and without pedestrians, and then fatal accidents with or without drunk drivers. So as you can see, there is a good portion of the accidents that has pedestrians as well as drunk drivers.
So ultimately, the goal of this machine learning model is to take in a bunch of inputs like the street width, the speed limit, as I mentioned, and produce a number that represents the safety of the street. This can be useful in many fashions. It can help justify the sidewalks we choose to paint this semester to cities so they approve it. As said earlier, we have to convince different mindsets. This model can also be used by the city in the long run to help evaluate which streets to place sidewalks on, or if any precautions should be put in place for the more dangerous streets. Due to a lack of available output data showcasing the street safety, we'll have to utilize a sigmoid function to produce output, which is a number that represents how safe the street is. The sigmoid function essentially produces a probability that a street crash will or will not happen. The probability can be used, in our case, as actual output we provide for street safety. Two different algorithms utilize a sigmoid function, the logistic regression and a neural network. And the way that a sigmoid function works is essentially we can assign, for example, the car will crash, the street is not safe to 1, or the car won't crash and the street is safe to 0. And the curve represents the probabilities that will happen, and that will be output.
Yeah, so with the overall problem being connectivity and the disconnect between citizens and residents of Harker Heights with other areas like parks and commercial zones, we've kind of designated some locations purely based off of that connectivity issue. Kind of basically building a theory that we want to test or prove with the numerical data that the computer science majors are going to be collecting. And so this is our first. We have two proposed areas, and this is the first one, East Beeline Lane. In the pink circle is HEB, and so the street is in the blue line, and it kind of just shows that it goes right through a major residential area. It has connectivity to a park, and obviously takes a major commercial area, HEB, and directly connects it to all the outlying areas. And then the second proposed street is going to be South Amy Lane. It runs perpendicular to East Beeline Lane, and it connects 3 commercial districts, the 2 in the pink circles and then the 1 in the middle. The major commercial locations and designations are Cinemark, Target, Bed Bath & Beyond, and other multiple restaurants and shops, which is, that's what we're looking for. We're looking to connect major commercial zones to outlying residential areas. Another thing that's unique and special about this the street is that the street that runs parallel to the commercial area where Cinemark and Target and all those other major stores are is Indian Oaks Drive, and that street already has an existing sidewalk. So if we can put a sidewalk on this street, it would be able to connect the project that we're working on to already existing sidewalks to increase the connectivity throughout the area. And these are just some current street views of Beeline Lane. You can see it's a pretty wide street, doesn't have any sidewalks or anything on it right now. They're about 45 feet in width. You go to the next one. Yeah, so they're very identical. They're both 45 feet. This is what we're going to be looking to work with. And so this is what our streetscape plan is hopefully going to look like. It's going to be very simple. It's going to keep driving lanes in the middle and protect the bike lanes and the pedestrian designated areas from that vehicular traffic, the bike lane and the sidewalk. So when it comes to logistics and finances, with our budget that we have, we were talking to a local paint store in Harker Heights, and we were able to figure out that we could get sidewalk paint for $30 a gallon. 1 gallon of paint will cover about 300 to 400 square feet, depending on the type of surface. More permeable surfaces being the ones that will take up more paint and decrease our square footage, and less permeable ones increasing square footage. One factor you have to think about there is the environmental impact. Less permeable surfaces will harm the environment because of stormwater runoff. So that's one thing that we're going to have to think about. With our $1,000 budget, this allows us to buy around 33 gallons of paint, and with about 33 gallons of paint, that affords us to have about 9,900 to 13,000 square feet. So this picture down here just kind of shows, how much, how much of the street that we could paint using that math. Basically, 1,084 feet, roughly 1,100 feet is the exact number, would be the distance that we could go with our proposed budget.
Regarding next steps, for the CS side, we need to finalize which inputs that we collected will actually use for training the model. We need to collect the data, we need to differentiate the training data and the testing data to train a model with. We also need to determine which machine learning model we'll use. And then we'll start training model into training data as well as refining with the testing data. And I think Carl is going to talk about the urban planning next steps.
From an urban planning perspective, we need to do some research on how to implement the planning of the sidewalks that we talked about earlier. We need to precisely pinpoint the locations that we want to do so in, and organize some logistics, how we're going to get this done, look at some pricing points, and also do some research on the longevity of the paint, how long it'll last. And we should use some case studies from other cities that have used a similar tactic and get all the details on all of those. And then meet again with Harker High staff after compiling all this information.
And here's references.